which was angles and looking at angle measurement specifically. And normally we measure angles, and we talked about angles in terms of measuring them in a degree unit. The problem with degrees is that they were man-made, which kind of sucks, because when we do things mathematically, we need them to have some kind of natural, foundation. We need something sturdy for them to sit on. We don't want something that is necessarily just created on a whim. And the reason, again, and hopefully you still kind of remember this, is that we essentially said that in a circle, because this circle essentially represents unity, perfection, completion, they had always kind of used 360 degrees, and this is thought to be connected with the days in a year, with the cycles of seasons, everything kind of broken down into this number. This unit is also can be divisible by many, many numbers. It's, by 2, by 12, by 15, 4, whatever. And so it's really easily to divide up into slices, which is very, very convenient. But for us, it's not very, very convenient. And a lot of problems, if we're measuring in any kind of construction, we'll use degrees, but when it comes to a mathematical, scientific, any kind of natural sciences kind of courses, we're going to be using, again, what's called a radian measure. And just to highlight again, what radian essentially kind of comes from is the radii stands for radius, or radii, plural for radius, and the an again came from the word angle. So when we're actually measuring these things out in a circle, what we're measuring is the angle created by one radius around a circle. So in the case of the circle that I've drawn up here, if I put a line, let me try to move it because it's not really like centered on anything. So let's say right there, and I'm going to fix the size a little bit. There we go. So now it's kind of a little bit more symmetrical, way better than I could draw it on the board. But I'm just going to put kind of a horizontal here just so we have a marker. The center of the circle is right here. And so essentially, if we were to measure out this radius, this distance here as 1, 2, 3, 4 total units, if I was to travel 4 units around the circle, should put me about right in here somewhere, not a straight line, somewhere about right in here. If I travel this distance of 4 steps, 4 units, this is 1 radius. And if I drew a line to this endpoint here, the angle that I'm creating is known as 1 radian. Because it is this rotation, this shape, this figure was created by traveling 1 radius. So therefore the angle would be called 1 radian. And I stress this a lot in class, stressing it again a lot here, because I think it's really easy, again, to kind of glaze over, again, what this is, because again, when we're using them, they can be pretty practical in their applications, but actually knowing and being able to describe what we're talking about is a little bit more difficult. So I just want to kind of give you that option again to kind of look at. All right, and so now that we have this kind of radian thing figured out, if you recall, I'm going to go through and copy this circle because it's so pretty. What we did is we took circular objects, and you kind of had different circular objects that you brought in, and we ended up noticing that in terms of the number of radii that can fit around the circle, we could fit a number, pretty much essentially 6, so approximately 6 and a little bit more radii around a circle. So to kind of put in that starting point again, here's my center. again, if this is my starting location here, and this is my initial side, if we were to travel all the way around the circle and go all the way around, we could fit at least 6 and a little bit more. And we ended up figuring out that that 6 and a little bit more was roughly about 0.28. And we talked about how pi was essentially found because of this ratio, because 6.28 is 2 pi. And so we ended up saying that if I start in the standard here, where this is going to be my 0 angle, my 0 radian, going all the way around would be exactly 2 pi radians. And so now one full circle would be worth 2 pi radians in the grand scheme of things. And if the whole circle was then 2 pi, if I only went half, then this would be half of 2 pi, or pi. If I went half of pi, this would be literally half of that, and literally half of pi radians, so pi over 2. If I was to travel in between pi and 2 pi, this would be 1.5, or 3 pi over 2, which is located down here. And so we essentially then have our main quadrants broken down. You can think about this in terms of the x and the y axis. We're not going to deal with that in this video. In the next video we will, and we'll kind of put this then on x and y. But for now, we're just kind of look at it like it is. Because the next thing that we ended up doing is we said, okay, if I know that there are 2 pi radians in a circle, and I know in terms of degrees there's 360, then these two numbers are equal to one another if I'm traveling one full rotation, right? So one revolution is equal to 2 pi in radians, or 360 in degrees. And so we ended up starting to make some conversions and some relationships by going through and saying, again, dividing this by 2. So dividing 2 pi by 2, I would get pi is equal to divide 360 by 2, 180. And that makes sense because we already know that if I travel 180 degrees, which would make this straight line, this is 180. Well, that is represented here now by pi. And so we can see that here in my relationship. And we ended up continuing to do this in class. If I continue dividing by 2, pi over 2 is therefore 90 degrees. Divide by 2 again, pi over 4 is 45. And so I kind of gave you this table just to really just kind of show, the kind of some basic relationships between some of these numbers and how we can convert in between the two. The big kind of question comes up then is, all right, well, what is 3 pi over 2? Because that's one of the ones on the circle that we haven't thought about. What is this in terms of degrees and in terms of doing that measurement? And how we convert is we're going to use these numbers here and write it as a conversion ratio, factor, however you kind of want to look at it. It's what I'm going to multiply by if I want to convert. And so if I want to convert radians to degrees, what I'm going to do is I'm going to multiply by 180 over pi. If I want to convert degrees to radians, I'm going to multiply by pi over 180. These were the fractions, these were the numbers that I wanted to do. So like I said before, if I want to try and figure out what is 3 pi over 2 in terms of degrees, I can take 3 pi over 2 and I'm going to multiply it by 180 over pi, because this is the direction that I want to travel. And I'm going to go through and I'm just going to follow my normal multiplication rules. One thing I can kind of do at the very, very beginning is I can say, okay, pi's will cancel because I have 1 here up top, 1 here on the bottom. And then I'm just going to multiply straight across. 3 times 180 will come out to be 540. And I'm going to divide this by 2. This answer will be in degrees. And I get 270 degrees. And so 3 pi over 2, another way to look at it, is 270 degrees. Again, pi is 180. Pi over 2 is 90. 0 is 0 degrees. 2 pi is 360. And so with these rules here, then we now know how to also convert. Okay, now I want to take a look at a circle, essentially the unit circle again. Now the unit circle, just as a reminder, is specifically a circle of radius 1 unit. Thus the name unit circle specifically. This can be 1 foot, 1 mile, 1 kilometer, an inch, centimeter, a toenail, whatever unit you want to use. We can measure this as that. And so I've got a circle drawn right here on the left. I'm going to go ahead and draw in the horizontal. The center is located right here. And so just for now, imagine that these dash marks don't measure units or whatever, but this overall is just one. This entire thing here is just one unit. Let's just say 1 foot in terms of a radius length. All right, and what we ended up doing is after we started talking about the radian measure and how we could convert, we started looking at now specific marks or radian measures specifically on the unit circle. And the way that I taught it in class was I told everybody to take the unit circle and to first break it into, and we started with 4 equal slices. And so it was this idea of cutting up the circle. And so we took, I had you draw a circle, whoops, not the eraser. I had you take a circle and do the vertical. And notice now that this breaks it up into 4 equal slices. And I kind of asked, okay, well, if I take an entire circle, which is worth 2 pi, and I want to break it into 4 equal slices, I'm literally taking this 2 pi over 4, or 2 pi, and dividing it by 4 to tell me that each slice would be worth pi over 2. So if, again, my starting point is here on the far right side, if this is 0, then I'm taking exactly pi over 2 steps to get to the next mark. And so this would be pi over 2. The next mark would then be here at pi, and then the next mark here would be at 3 pi over 2. This is also a good time just to kind of remind you that when we travel around the circle specifically, and when I'm doing these marks, starting at 0 here, when I go counterclockwise, this is the positive direction. If I want to rotate clockwise, this is the negative direction. And so the sign of your angle is always going to tell you how you will travel around the circle, since there are now 2 directions we can go now that we've placed this and always marked 0 to be right here. And so that way, when I say draw an angle or point to where pi over 2 is, we will always point to positive pi over 2 here. If I'm starting at 0 and I want to go to, say, negative pi over 2, then I'm going to travel clockwise pi over 2, and notice how that lands at the same spot as 3 pi over 2. So then there's some kind of connection between negative pi over 2 and 3 pi over 2 because they share the same spot on the circle. We call this coterminal specifically, and I'll give you a couple of examples here for that once we kind of draw out the rest of the unit circle. Now the next thing we kind of walked through is I said take the circle, and what I'm going to do is divide it into the next step was 6 equal slices. And so I'm going to copy the circle that I had. I'm going to paste it down so we've got it essentially marked. Here's my center. And I'm going to go through and divide this into 6 equal pieces. So 6 equal slices is going all the way around. So that means in the top hemisphere, I'm going to have 3 equal slices. So I'll put one slice approximately about right there, one slice approximately about right there. It's roughly about 3, and then I'll kind of continue one slice here, one slice here. As you can tell, this isn't perfect, but it'll kind of at least just kind of get the point across. And if I want to know what each slice is worth, we did the same technique where I'm going to take 2 pi, which is the total worth of this entire circle. I'm going to divide it by 6, which means each slice is going to be worth pi over 3. So as I travel, again, in the positive direction, which is counterclockwise, this first radian measure is going to be worth pi over 3. This next measure will be worth another pi over 3, so 2 pi over 3. And then if I go another over 3, this will be 3 pi over 3, or pi. And so notice essentially what I'm doing is starting at 0, I'm adding pi over 3. So 0 plus pi over 3 is just pi over 3. If I add another pi over 3, I add their numerators, so that'll give me 2. Add another pi over 3, that would be then 3 pi over 3, or pi, because the 3's I made a whole number. And so this is how the counting essentially continues to work, because now that I'm at pi, to get to the next mark, I'm going to add another pi over 3. Well, this is 3 over 3 here. And so when I add another pi over 3, we're going to get an improper fraction. It's going to be now 4 pi over 3. And then if I add another pi over 3 to that, that'll now be 5 pi over 3. Add another pi over 3, 6 pi over 3, and it's going to get me now to 2 pi. And so we essentially have then, if I divide it into 6 equal slices, we have these marks on the circle, which I'm going to clear off this scratch work so we can kind of see it here. The final circle that, well, not the final, but the next circle would be to take our circle and divide it into 8 equal slices. And so when I take my circle and divide it into 8 equal slices, here's my circle now, each slice will be worth 2 pi over 8, or pi over 4. And so I'm going to go through and mark those off. 8 equal slices means 4 slices up top and 4 slices on the bottom. What's really nice about this is that is essentially taking my circle that had 4 equal slices and then dividing each of these in half to give me the perfect quarter slice on each one, here and here. So now I have 8 equal slices. Again, as I travel around the circle in the positive direction, this would be plus pi over 4. When I add another pi over 4 to this, this would be 2 pi over 4. Add another pi over 4, 3. Another one is 4 out of 4, or pi. 5 pi over 4, 6 pi over 4. Oops, not let me draw it. And 7 pi over 4. Adding another would give me but 8 over 4, or 2 pi. And as I've gone around and done the circle, some of you may remember that some of these can be simplified, aka the 2 pi over 4 here and the 6 pi over 4 here. Notice that these line up exactly with pi over 2 and 3 pi over 2, which is what you would normally see in their place. I left them just so you could easily see the counting. And then if you need it, you can kind of leave it that way, but as you get more used to it, hopefully you'll kind of keep putting in this instead. And so that's 8 equal slices. The final one, just to get a new page, again, fill in the circle. Here's the center. Is to take this and divide into 12 equal slices. One observation just to kind of make with this is notice that we've essentially increased the number of slices. We've gone 4, 6, 8, increasing by 2, and then so you would imagine 10, but we're actually going to go up to 12. And I'll point out the reason behind that once we get this drawn out. And so again, if I'm doing 12 equal slices, that's going to be 6 slices up top, 6 slices on the bottom. Each slice will be worth 2 pi divided by 12, which is pi over 6. Let's see, I'm going to draw here, here, try to again make these as equal as I can, here, here, here. That's not too bad. And then I'll keep going. Here, here, here. Last one. Oop, didn't give me a straight line. Last one. There. All right, so now I've got my unit circle. It's been divided into 12 equal slices. Each slice is worth pi over 6, so going again in the positive direction. So it'd be pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, and then 6 pi over 6, which again is pi, which makes sense because we made it halfway around. But if I was to continue counting, another pi over 6 in the positive direction would give me 7 out of 6, 8 out of 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, and 2 pi, which is 12 pi over 6 when I made it all the way around. And like before, when we looked at the divide by 8 equal slices, there were some angles we could simplify. It's actually the same thing here. I can go through and actually simplify some of these, and again, this may stick out and remind you, but essentially here at 2 pi over 6, this is pi over 3, 3 pi over 6 is pi over 2, 4 pi over 6 is 2 pi over 3, 8 pi over 6 is 4 pi over 3, 9 pi over 6 is 3 pi over 2, 10 pi is 5 pi over 3. And so this kind of gives me the simplified version here. And the other kind of connection is, notice that in this one, I essentially have my pi over 3, my 2 pi over 3, 4 pi over 3, and 5 pi over 3. These are the same measurements that we actually saw when we divided everything into 6 equal slices, which makes sense because 6 goes into 12. And so this is looking at almost like a minimized or a hyper-focused version here of the 12 slice circle with these numbers. And so where the unit circle essentially then comes in is we're taking pretty much all of these circles and essentially overlapping them on top of one another. And when you do something like that, I'm going to go through and kind of simplify what we're looking at. So I'm going to take this entire circle here. I'm just going to copy it. I'm going to paste it. And I'm just going to kind of clean this up. So that's pi over 2. This only simplified to pi over 3, 2 pi over 3, This we looked at as just pi. This we looked at as 4 pi over 3, 3 pi over 2, 5 pi over 3, and 2 pi. So let's kind of make this a little bit neater. I know this is super interesting to watch me clean this up. Don't lie. Pi over 2, pi over 3. Okay, and so really the only things that are missing is my over 4s when we divided everything into 8 slices. And so I'm going to put those in now. The pi over 4s actually sit right here in the dead center between these two. And this spot was pi over 4. This spot was 3 pi over 4. This spot was 5 pi over 4. And this spot, 7 pi over 4. And now what we have here is the unit circle. This is the unit circle, or at least the beginning of it. Specifically the radian measures here, 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 all the way across. And there's a couple observations that we can make with this before I kind of speak to again why these are the most important ones to know. And that's one, if you're to notice along the horizontal axis here, the x-axis, notice that is where my pi over 6s are. So pi over 6 and 11 pi over 6, 5 pi over 6 and 7 pi over 6. If you focus on the y-axis or the vertical axis for the circle, the values that hug it are 2 pi over 3 and pi over 3, as well as 4 pi over 3 and 5 pi over 3. So there's a couple patterns that are essentially sticking out here. Specifically, again, any of the numbers over 6 are along the horizontal. Any numbers that are over 3 stick around the vertical. And the over 4s go right in the middle. Otherwise, we have all of our specific quadrants again still listed that we found earlier. And so again, what this essentially represents is some special radian measures. And just to hopefully get some kind of connection with what you did in geometry, you should recall like special has a specific connection with things that you talk about from geometry. You specifically kind of focus on special right triangles, which involve special angles. Those angles are 30, 60, 90, and then 45, 45, 90. Well, these are the angles for triangles, specifically right triangles, in degrees. My question is, what are they in radians? Well, 30 degrees is pi over 6. 60 degrees is pi over 3. 90 is pi over 2. 45 is pi over 4. And so if you were to kind of notice that all of these radian measures that correspond to the special angles in a right triangle are over 6, over 3, over 2, or an over 4. And this is really, really important because this helps explain the numbers and why we cut the unit circle the way we did. Because if you look back at our circle, every specific radian measure that we have here is over 3, 4, 6, or 2. In other words, all of these angles correspond to some kind of combination of these, of 30, 60, or 45. In the next video and the newer material that we're going to look at is going to then really start focusing on this idea and kind of reviewing the special right triangles. Like why is 30, 60, 90 so important? Why is 45, 45, 90 so important? And then more so, trigonometry is now going to help describe, okay, what's the connection between these? And really, why is the unit circle important? Because that should be kind of the first question on the top of your head. Why talk about this? Why is this relevant today? Um, what's the use for this? And so, to help kind of explain that, we will look at that in the next lesson.